Hello, Honors Algebra 2, Notes, Chapter 1, Section 4, Solving Inequalities. Okay, so let's recall this notation right here. This means x is an element of. So in quotes, we'll say this means x is an element of. Okay, so it's going to be some set. And we'll see how we're going to use that at the bottom of the page with our examples. Interval notation. Well, you see, interval notation is used with inequalities because there aren't just certain specific answers to an equation, like for equations, rather, we might end up with x is 2, or if it's quadratic, sometimes we have two solutions, like x is 5 and x is 12. And so we would put those items in set notation and says, the set of all x that makes the equation true is when x is 5 and 12. Or x is an element of the set that contains 5 and 12. Interval notation involves starting and stopping at some point, or maybe starting at a point and going in the direction of positive infinity and so on. So we're going to say here that this is used, interval notation is used for inequalities. Okay, so it's used with inequalities because you should be familiar with inequalities when you're solving them and graphing them. You've got some shading going on, indicating that there are solutions in the shaded set. And so we use the interval notation to denote that. So used with inequalities since solutions are not limited to one value. Just like I stated before, when we solve equations, typically we are limited to one or two or maybe even three values, depending on the type of equation that we're solving. So also with interval notation gives specific starting and stopping values. And maybe it doesn't stop when we go to infinity, but we'll talk about what that looks like. Okay? Well, the interval notation is going to give us specific values. Okay, the brackets. You'll see interval notation using either brackets or parentheses. These are brackets. If you notice, it comes straight across here, down, and then straight across over, versus a parentheses. Parentheses are rounded. Okay, these are not. This got like a straight up and down vertical bar. Okay, so we're going to use brackets when the value is included, or when the value is part of the set. In other words, in your inequality, you're going to see that equal to. So when it's equal to, use the bracket. And before, in Alg 1, you were used to seeing the closed dot. We're not going to graph with open dot and closed dot, so please don't do that in your homework. We're now going to graph with interval notation. And then we're going to use parentheses when the value is not included. Okay? When the value... And when I'm saying the value, I'm talking about either my starting or my stopping value, okay? So, maybe x is between two values, -3 and 12. Well, if -3 is part of the set, I'm going to use a bracket. And if 12 is not part of the set, then I'm going to use a parenthesis. So that's what I'm talking about when I say when the value is included. Use parentheses when the value, and this really is known, the value is like kind of the boundary point, okay? Boundary PT for point. When the value is not included. So we'll say here that it's not equal to. It's the old-fashioned open dot. But again, you're not going to give me any graphs with open or closed dots. That's a no-no. Okay, and don't forget about this rule when we're solving inequalities. You can't forget about this rule. You must do something with the inequality symbol when you multiply or divide by a negative. It's not multiplication or division that does this. It's the negative, that switching of the negative. Do you remember what you have to do? Maybe you do remember. If you don't, I'm going to tell you. You have to either switch or flip the inequality symbol. When you multiply or divide by a negative. And I'm going to show you why. You could choose to write this down or not. Doesn't really matter to me. Sometimes it helps. I'll ask you, is 4 less than 6? And you say, sure, 4 is less than 6. That's true. Now, if I either divided or multiplied both sides of the inequality by a -1, okay, so if I multiply or divide each side by -1. Okay? So if I multiply 4 by -1, I get -4. And if I multiply 6 by -1, I get -6. And if I keep that symbol the same, is that a true statement? Is -4 less than -6? And you say, well, no, it's not. -4 is to the right of -6 on the number line. -4 is greater than -6. This is false. But if I flip that symbol, then this is true. And that's why you have to flip the symbol. It's because if you don't, it gives you a false statement. Okay? So that means you or we or everyone has to flip the symbol from this to that to make it a true statement. Okay? All right, on to solving some examples. 5x subtract 3, when is that greater than or equal to 17? Well, folks, we solve these inequalities just like we do equations. We need to isolate the variable x. So again, I like to write the original problem down so I don't booger up the original problem. I like to see the text on my note sheet. And I say to myself, all right, well, this is an x term. It's a variable term. This is a constant. That's a constant. So I'm going to take 3 to the other side by addition. And I end up with 5x. I did not multiply or divide by a negative, so I keep the inequality symbol the same. 17 plus 3 is 20. Now I see an integer being multiplied with a variable x. And I know to get the x by itself, I bust apart the multiplication by division, and so I see x is greater than or equal to, well, 5 divides 24 times. Again, I do not have to flip the symbol because I did not divide by negative. So this is my solution, and to graph it, now we're going to draw a number line, and at the very least, I need to see 0 on your number line. 0. I also need to see this boundary point on your number line. 4 would be to the right of it, okay? And now 4 is included. So because it's equal to, I need to use a bracket. And I'm going to graph this on the number line, okay? Equal to means closed dot, but we're not going to use closed dot. We're going to use a bracket, and then we're going to shade to the right. Now, folks, make sure that you are drawing this extra arrow and shading that arrow. Don't just draw the shading up to this arrow, because these two arrows mean two different things. This arrow belongs to the number line, and this arrow belongs to the shading. So if you take a shortcut, I'm probably going to take a point off for you doing that on a test or a quiz, okay? So make sure that you have the thick shaded arrow. And so we'll say the solution to this is x is an element of the interval 4 to infinity, because I'm shading to positive infinity. Remember, this side is positive infinity, this side is negative infinity, okay? And then 0 separates the positives and the negatives. This is being shaded to positive infinity. So start at 4, include it, and go to infinity. Keep in mind, you can never, 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 ever bracket infinity. Infinity always has the round parentheses. The side of the infinity is round, so parentheses is round on that as well. Okay, so this is my answer in interval notation. From 4, including it, all those values, 4, including 4, and all the values after 4 are going to make this true. And you can check it. You know, pick a 10. Let's go up here. Pick a 10. 5 times 10 is 50. Subtract 3 is 47. Is 47 greater than or equal to 17? Sure is. Okay. So choose a value on the interval to check it. All right. Example 2. 14 subtract 2 times the quantity x minus 7. When is that less than 38? What values of x would make that less than 38? Well, I've got some algebraic manipulation to do. I got to solve for x. X is tied up in this grouping here. So I'm going to just treat this just like it's an equation. I'm going to distribute the negative 2. So I've got 14, subtract 2x. And then negative multiplied with negative is positive. 2 times 7 is 14. Less than 38. Combine like terms on the same side. 14 and 14 is 28. So I've got negative 2x plus 28. Excuse me, less than 38. Combine like terms on opposite sides. I'm going to show, I'm taking that off, and I've got negative 2x is less than, when I subtract 28, I get 10. Now here I have to divide by a negative. Okay, when you divide by a negative, you must flip that inequality symbol. And 10 divided by negative 2 is negative 5. Okay, this is my answer in terms of an inequality. And then I want to graph this. So remember what we said before, we want to see negative 5 on the number line for sure. We also want to see where is 0 with respect to negative 5. So I know 0 is greater than negative 5. I'm going to place negative 5 over here. I'm going to put 0 over here. You could put the little tick marks on the number line equally spaced, but I don't know. I don't think you need it. This is not equal to, so use parentheses, okay? I'm going to use it parenthesis on negative 5. And you have to ask yourself, which way am I shading? I'm shading to the right, greater than negative 5. So I put a parenthesis at negative 5, and I'm going to shade, and I'm going to give the thick shading arrow. I'm going to give my answer in interval notation. Excuse me. My answer is x is an element of parenthesis negative 5, again, to infinity. See the difference between the brackets, when to use bracket, when to use parenthesis? And then again, of course, you can check. But remember, you have to choose a value that's on this interval. 0 is on that shaded part, so I'm going to pick a 0. Okay, if I go back up here to check it, you know, 0 minus 7 is negative 7. Excuse me. Negative 7 multiplied with negative 2 is positive 14, add 14 is 28. Is 28 less than 38? Sure it is. Okay, if you pick a value over here to the left of it, say like negative 10 or something like that, you should get a false statement when you check it back in the original. Okay? So if you have questions on these, you know, make a post on the homework discussion. Make sure you make your posts early enough. I mean, if I get it after 4 o'clock, you might be having to wait till the next day. Just keep that in mind. Okay, example 3. I've got variables on both sides and constants on both sides. No big deal. I just treat this like an equation. I'm going to copy down the original problem. Negative 4x subtract 7 greater than negative 3x subtract 8. I'm going to take negative 3x over here by addition. That leaves me with negative x subtract 7 greater than negative 8. I'm going to add 7 over here. I get negative x is greater than, excuse me, negative 1. And when I divide by a negative, I've got to flip that sign. And I've got x is less than 1. Do I use a parenthesis or do I use a bracket? And you say, correct, parenthesis, because it's not equal to. Here's my graph. Here's 0. Here's 1. Positive 1 would be to the right of 0. And I'm going to use a parenthesis, but this time I want values less than 1. Folks, that's on the negative infinity side. Okay? So I'm coming like back this way, parenthesis on 1, because 1's not included, and I'm going to give my thick shading arrow. And now how do I write my interval? Well, we always write the interval from left to right, just like a book. We want the smallest thing first to the biggest thing. If I flip over my page, I want the smallest thing to the bigger thing. Infinity is bigger. Even infinity is not a value. It's not a number. It just keeps going and going and going. So always positive infinity would be on the right of your interval. But if we're involving negative infinity, look at where it is with respect to elements on the number line. It's on the far left. So negative infinity is always on the left side. Remember, we can never bracket infinity, so that's negative infinity, up to 1. 1 is not included in the set, parenthesis, and we say that x is an element of negative infinity to 1. You could check it. 0's in the shaded part. Substitute a 0 in here. So we're like, okay, well that would go away. That equals 0, and negative 3 times 0 is 0. Is negative 7 greater than negative 8? Yes, it is. It's to the right of it, and numbers to the right would be greater than. So that's true. So again, check by choosing a value on that interval. I can't pick a 2 to check because 2's not in the solution set. Got to make sure you're picking something in the shaded part. Okay, the last one. I got distributive property here. I'm not going to copy the original problem down because the only thing I'm doing is distributing. See, I copy it here when I know I'm going to cross stuff out. So here we've got 7 times x is 7x. 7 times 3 is 21. It's negative. Less than or equal to 7x plus 4. All right, I'm going to put the 7 x's together. I like to keep my x on the left side because I like to read my inequality in terms of x. So I know I'm going to subtract 7x over here, and oh boy, that goes away as well. So in this case, the x's went away. We saw this with equations. You have to ask yourself, is this a true or a false statement? Is negative 21 less than or equal to 4? And you say, yes, it's true. And since this is true, then all real numbers are solutions. All real numbers are solutions. And so I'm going to draw a graph, put 0 in the middle, and what I'm shading here is the whole entire number line from positive to negative infinity, or from left to right, negative infinity to positive infinity, including the 0. There's no stopping. It's just everything. So x is an element of negative infinity to positive infinity. Any value I choose off the real number line would make that a true statement. Now, remember, what I want you to remember is that you could pick any value on here and check it. It's going to get a true statement. The other thing I want you to remember is that if this were to be false, then we would have to say there are no solutions. Okay, and that would be empty set. You wouldn't write it in interval notation. You would just write the empty set. So that's what I wanted to say. Now, the homework on page 29, right there at the bottom of the page, it's on page 29, 1 to 13. I have in my notes that it says don't graph. Now, I'm not sure what it says in the book, what type of graphing, but just, you could do these graphs on the number line, but I'm not sure what's in there. You don't need graphing paper if it's going to require you to graph. Or maybe I don't have the answers with those graphs. I'm not sure. I'll type it and put it on the agenda. Okay, remember, if you have any questions, post a comment on the homework.